we get to talk winter, finally.
Yep, finally. That's my favorite season.
And we'll officially kick off here. We're hitting the 2 o'clock Central Time hour. And again, the focus today is winter weather. We're really thankful all of you have joined us today. It's kind of one of those topics where, I mean, winter can be dangerous, but it's also kind of fun. You think of the snow and think of these cold blasts and bundling up. And I always think of the Christmas Story kid that's got that giant, outfit on, trying to stay warm. But in the weather world, winter weather can drive a lot. It can disrupt supply chain and can drive trading markets and all kinds of stuff. And that's what we're here to talk about today. So I'm happy to have Steve Strum with us. Steve is in Tulsa and leads our extended forecast services. And we got Eric Faulkner in South Carolina, which doesn't get all that cold, but he grew up in the north, so he knows a lot about cold weather. Pittsburgh, right?
Yep, Pittsburgh. Yeah,
Pittsburgh, awesome. And he leads up our business development efforts in the energy trading world. So we got a couple experts with us to talk winter weather today. I'm going to turn it over to Steve Strum and let him get into our winter weather outlook here from WeatherOps for this season.
All right, great. Yeah, can you see the slides here, Rennie?
It is perfect.
All right, good to go. So we'll go ahead and start by looking at some of the historic winters in the last 10 or 12 years or so to kind of get some background of where we've been in recent years. And this plot here kind of just shows everything from the winter of 2006, 2007 to this last winter. And the ones that have red boxes around them are years where we had some type of El Nino event going on. Now, the 2015, 2016 winter had a very strong El Nino, and those type of events tend to be very warm across the country, whereas the weaker to moderate El Nino events like 2014-15, 2009-10, and 2006-7 tend to see a lot more cold. And so that's one thing that we're kind of looking at for this upcoming winter. We've had the El Nino developing this year, and it's kind of in that weak to moderate range right now, and looks to pretty much stay that way as we head into the winter season, which is now getting fairly close, only about a month away or so. And so we're looking pretty closely at that. But you can see here, just overall year to year, we've had quite a bit of variability. We've had some extremely warm winters, some extremely cold winters. Obviously, the big 2013-14 winter that was exceptionally cold, and then we've had the 2016-17 and 2015-2016 winters that were just extraordinarily warm. So we've had a lot of extremes. And the question is, are we going to be tending towards one of those extremes this winter, or be somewhere in between like we were last winter? And there's actually been a trend towards having fewer normal winters and more winters on the extremes in the last 10 or 20 years. This plot here shows looking at heating degree days for the November to March period, totals for each winter season. The years there indicate the year that winter ended. So the 2019 value there on the right is actually the current forecast for this upcoming 2018-2019 winter. And the trend line there shows that historically there's been sort of this long-term trend of gradually warming winters with fewer HDDs every winter. But there's a lot more variation there that we'll look at here in a second. I also highlighted the years that had a weaker moderate El Nino there in that sort of orangish peach color to kind of give you an idea of what the winters typically have been when we've had a similar type of ENSO regime. So that kind of gives you some historical context in that regard. But again, if you kind of look at these the trends in a little more detail here and break things down, this is kind of complicated here, but I basically threw on a whole bunch of trend lines. And one thing that's been interesting is that if you look at just the cold winters by decade, there's actually been no trend at all. That blue horizontal line there indicates the long-term trend for the coldest 50% of winters each decade. So if you take the 5 coldest winters of each decade, average them together, there's been no trend at all in that average temperature. But the red line there indicates a trend in the warm winters. And so if you take the 5 warmest winters of each decade, there's been a very strong warming trend. So really what we've seen is that the warm winters are getting very warm and trending warmer with time. But the cold winters, when we have them, are pretty much staying about as they have been for the last 10, 20, 30, 40 years. So what we're seeing here is a larger year-to-year swing in temperatures in many cases, where the warm winters get really warm, and then the cold winters, when we have them, are still pretty consistently cold. Now, also, there's been a slight actual trend towards colder weather during the El Nino years, during the last, say, 30 or 40 years, where the last several El Nino winters, if we exclude the really strong 2015, 2016 winter, have actually been a little bit colder than the ones that we saw in the prior couple of decades. So that's kind of an interesting trend there as well. So the bottom line, though, is that while the long-term trend has been warming with time, when we have cold weather, it's actually been pretty consistently cold relative to past decades. And really, the trend has been on the warmer winters. And the reason for that is that we're seeing, this increasing trend in temperatures in the Pacific Basin. So the entire Pacific Ocean has been trending warmer with time, going back over the last 40, 50 years, kind of part of the longer term global warming trend that we're seeing in the ocean temperatures. And if we plot just the warm winters across the US, those red dots, the trend in warm winters has almost matched the trend in ocean temperatures exactly across the Pacific Ocean. And so what that's kind of telling us is that when we have a winter season that's dominated by flow off the Pacific, that's really what you have to look to kind of gauge what your winter temperatures will be. And so as we see further warming in the Pacific, the air that comes off that water is warmer, just from being over that water. And as it flows across the US, we have, warmer air coming across than we would normally see. And so years dominated by Pacific flow are very warm, but when we have a pattern that features blocking along the West Coast and strong flow out of the Arctic, the cold air that's coming down in the winter season is pretty much as cold as it was in the past. So that's kind of the key there. When you have a flow dominated out of the Arctic, you're going to be very cold, but if it's coming off the Pacific Ocean, it's going to be basically trending warmer with time going forward, as long as that trend continues. So we'll be watching that going forward, on a yearly basis, going out in the upcoming years to kind of gauge what the warm potential is on a year-to-year basis. So now looking at just the El Nino years, which again are kind of what we're looking at for this year, I've basically broken down the 5 warmest El Nino winters we've seen and the 5 coldest since 1981. And you can see there's a pretty distinct change. I mean, we've had some years that have been extraordinarily warm on the El Nino side. Again, the years that have been primarily very strong El Ninos, but also some extremely cold El Nino winters. And there's some distinct differences in the ocean temperature patterns between those two types of El Nino events. So when we have a strong El Nino, the bottom left-hand side shows the ocean temperature anomaly patterns for those strong El Ninos. The bottom right-hand side, when we have the more moderate events. And you can see that for the most part, you have stronger warmth in the equatorial Pacific and the central and eastern areas in those strong events. And you tend to see a stronger cold pool across the western Pacific, and also less warmth across the far northern areas around the Gulf of Alaska and up towards the Bering Sea. Now, in the years that have been colder, we've seen more warmth in the northern Pacific Ocean like we have this year, and the warmth in the eastern Pacific Ocean is much more subdued, and the cold pool across the western Pacific there around Indonesia is much more subdued as well, much more close to normal during the years that have featured a colder winter. And really the key is that if you want to have the warmest water on an absolute basis located kind of between Indonesia and the international date line to get sort of a favorable pattern for cold across the US during the winter season, and right now we have that. That could obviously change going forward into the winter season. Maybe it'll shift farther east than what it currently is. We'll have to watch that. But right now it's set up in a location that does tend to favor a colder regime, kind of like those colder winter trends you see there on the right-hand side. So one thing also we've noticed is that we've had a cold October across the central US, and some of the past El Ninos that have been cold winters have also had a cold October. I have 2002 here as an example, and you can see October 2002 has been very similar, or was very similar to October of this year, with a cold plains area and a warm southeastern US. And if you look at the SST patterns for those 2 years, they're both fairly similar as well, kind of a moderate El Nino type of regime developing in the equatorial Pacific. We had that warm pool in 2002 in the Gulf of Alaska like we have this year. And so overall, some kind of a similar regime set up in terms of the ocean patterns to some of those colder El Nino winters to what we have in place this year. So if you look at all those years where we had an El Nino and we had a cold October or a warm October and kind of group those together, you can see the years that had a cold October tended to see a warm November followed by a colder winter across the central and eastern US, while as the years that had a warmer October across the central US tended to see more cold in November, but then a very mild winter, especially across the north central part of the country. So definitely a kind of a very distinct grouping here in patterns between the warmer and the colder El Ninos. And again, with the cold that we've seen this October across the plains and the current state of the ocean patterns does tend to point us towards that colder set of El Nino years this year. Now, obviously, again, we'll have to watch the strength of the El Nino. If it does get stronger, that could promote, potentially less cold for the upcoming winter season. Now, a couple other things are kind of sort of on the opposite side of the favorability spectrum. One thing we look at sometimes is the QBO, or the quasi-biennial oscillation. That's an oscillation in the winds in the upper part of the atmosphere. And when it's positive, it's basically less favorable for a negative Arctic oscillation. You tend to see a flatter jet stream pattern in general. And right now it's negative, but it's trending positive. And so the current expectation is that may trend positive by the winter season, or at least by the second half of the winter season. And so that would be somewhat less favorable for cold this upcoming winter season if that trend continues. And then on the other hand, we have a very low period of solar activity, and historically we've had a lot of negative AO years when we've had low solar activity, and also we've had a tendency to see negative AO patterns with a more amplified jet stream that can bring more cold down when we have an El Nino in general too. So there's a lot of conflicting things on that side of the spectrum. So we'll kind of see how those evolve going forward and how the QBO evolves as we head into the winter season. So not everything is lined up for cold this winter, and so there are some competing aspects that we're looking at. But in general, the overall trend has been a little bit more favorable for cold going into this winter season. Now, a few other things to look at here. The 10-year trend has basically favored more cold across the central U.S. and more warmth on the East Coast and across the Southwest. However, if you look at some of the model guidance and the composite of ENSO, the composite of years that had similar ENSO features, the trend has been towards more cold in the Southeast. So the ECMWF model there on the bottom right shows that it's favoring a cold southern and eastern U.S. this upcoming winter season, as does the UK Met model. Both of those models are fairly reliable in terms of the longer-term models. Some other models, though, like the U.S. models, are actually favoring a little bit more warmth, although they still favor the warmth to be in the northwestern part of the country where it's strongest, and then closer to normal across the southeastern U.S. So overall, everything is kind of favoring a trend towards the southeastern half of the country being colder, or at least near normal this winter, while the western and northern areas tend to be a little bit warmer. So our actual forecast for this winter season there is in the middle panel there, you can see on the screen. And we're forecasting, again, a warmer than normal northwestern and kind of northern tier of the country, but a colder south central and southeastern U.S. And that kind of somewhat washes out in terms of the HDD totals. Our current forecast relative to that 30-year average is actually about 1% higher than the 30-year average. So a little bit colder than average looking at an HDD standpoint. And that's just because the Northeast is pretty close to normal, as is places like Chicago, where you have a lot of strong demand for natural gas during the winter season. So those areas are kind of dampening down the overall degree day anomalies a little bit more so than what the temperature anomaly pattern might indicate. But again, we have had some very cold winters with similar El Nino patterns like we have this year, like 2009-10 and 2002-2003. And so if we do see a trend in that direction, continuing like we are now, we could see something closer to that colder scenario on the left-hand side, which featured much more widespread cold, and that would in turn produce a stronger departure from normal for our HDD totals for this winter season. On the other hand, if the El Nino does get stronger than expected, we could see the pattern end up closer to that scenario on the right-hand side, which would end up averaging a couple percentage points above average for the overall temperature pattern across the U.S. with much less cold, and where the cold is, will be kind of confined to the far southern tier. So again, not certain yet. We still have a little bit of time to go before the winter season kind of gets going here, but overall, for the most part, the overall trend does favor a colder southern U.S. And kind of one last thing here before we wrap up, I wanted to compare it to what we saw last winter again. Last winter featured a lot of cold in the north central areas, but it was very warm across the south. So even though last winter was actually pretty close to average from an HDD standpoint, and this winter may actually be pretty close as well, if the current forecast verifies, still a little bit colder than last winter, there's going to be some very large regional differences. And so those could be very important depending on what you're looking at for your area. So certainly a far colder scenario this winter across the southeastern U.S. than last winter. But areas like the Dakotas and the upper Midwest, where propane can be very important in the winter season, those areas may end up quite a bit warmer than what we saw last year. And finally, here to look at snowfall totals, since everyone wants to look at that usually going into the winter season, our current expectation is for a snowier than average winter across the central and southern half of the country, especially across the mid-Atlantic areas. The left-hand panel shows actual departures from normal in inches. The right-hand panel there kind of shows a percentage departure from normal. Again, it always looks kind of funny when you try to show a map like that, because average snowfall is so low across the southern U.S. Like in Dallas, you see on average only a few inches of snow per winter season. So, if you get 1 or 2 inches of snow extra, that's a huge departure from normal on a percentage basis. But it kind of indicates the areas that are going to be most likely seeing that heavier snowfall this winter season. So that's kind of a summary here on this last slide. What we're looking for, again, odds favor more cold across the south and the eastern U.S. this winter season, a warmer northern and western U.S. Again, we'll be watching how El Nino evolves here. If it does get stronger than currently expected, that would favor more warmth. If it does kind of evolve as what we're currently expecting and kind of trend towards those 2009 and 2002 years, which were very similar, then we could actually see a little bit more cold and a little bit more snowfall than what we're currently forecasting for this winter season. So anyway, I'll pass it back now to Rennie, and we can go through the rest of the presentation, looking at some of the things that we can provide you to use this data in your trading operations.
There's audible cheers throughout our Norman, Oklahoma office. There's a 140% chance of above normal snowfall. That's exciting for us Oklahomans.
Yeah, we're hoping that we can see at least one good snowfall this winter down here.
Absolutely. Well, there's an incredible amount of detail and very thorough forecast, and really appreciate you putting that together. And you highlighted there were several factors that point towards a colder winter, particularly in the east and south, and a couple that maybe trended towards that not happening. How does that impact your confidence in the forecast when you see maybe more than not trends towards the cold, but a couple things that sway you away?
Right. Confidence has been increasing in general because we've been seeing more of the climate models kind of latching on to that same idea of a colder southern and eastern U.S. That really wasn't the case a couple months ago. We're seeing more of the models trending in that direction as well. And so they're, in general, most things are pointing towards that kind of scenario for this winter season. So confidence is getting pretty high, and we are going to see, a southeastern focus for cold this winter. Again, the intensity is still up for debate depending on how the El Nino evolves in the next several weeks going into the actual start of winter. But thus far, everything has been trending in that direction, which is increasing the confidence in the forecast. Sure.
Well, Steve, thanks so much. And to follow Steve's updates as the winter goes on, we have services available to do just that. I'm excited now to bring in Eric Faulkner, who leads up business development for our energy traders and anybody interested in long-range forecasting. Eric's been with WDT now for maybe 6 months, I think. And this is your second webinar to join us, so we're happy to have you in on the webinar. Eric, why don't you take everybody through some of the products and services that we have available and the different products they can use to follow the updated forecast as we go throughout the winter.
Yep, sounds good. Let me just share my screen here.
Love the
okay, can you see it all right?
We got it.
Awesome. Okay, so let me just go through this. So like Steve said, we're predicting a little bit colder of a winter than normal, especially across the southeast and parts of the eastern U.S. And there's a lot of things that we do that can help track the forecast as we move forward. So one of the things that we do, obviously, the seasonal report, which is what Steve's presentation was mainly about. So we actually forecast out to 1 year, but for this in particular, for the winter season, we do provide updates for our seasonal forecasts that are released twice a month. So we try to provide as many consistent updates as possible. Obviously, we can't update it every day because it won't change every day. But we not only want our clients to get an understanding of what our forecast is, but we want them to understand how the forecast is trending and how it is progressing, because confidence, even though we're a little bit more high confidence now with some of the latest model information, confidence is a little bit lower once you get further out into the extended period for a forecast. So the one thing that we do is we try to provide forecasts as much as possible on a seasonal basis, which is why we do it every 2 weeks. But we also have a few other reports, a main 1 to 15 day report that's in the shorter term, and then a 16 to 30 day forecast that's updated every week as well, just to, get a little bit more frequent of an update in the intermediate term there. We have a lot of data, so we provide weighted degree days for the U.S. On a national level, on a regional, state level, really any kind of level that our clients are looking for, we can provide that information. So those are some of our main reports that we offer. Aside from the reports, we do offer some real-time information as well, whether that be the weather model information. We provide all the graphics in real time as they're updating. We provide model trends, so you can get an idea of how the trend is in the 2 to 5, 6 to 10, 11 to 15 day period, which are very helpful when you're looking, at the next 15 days and you want to know what's going to happen beyond the 15-day period if the models are trending warmer or colder in either direction. Another thing that we have available on the website is very interactive graphical city forecasts. So we forecast for a number of different locations in the US, and we recently added Canada now onto our website. And you can get our forecast, but all the model forecasts there as well. And aside from the daily forecasts that are available graphically on the website, We also, produce hourly forecasts and daily forecasts that we send out via data files too. So all of that information is available. We have historical data. We have some archive forecast data. So anything you really need to be prepared for the winter season and any season, we do have available with our suite of products. And one thing that's a little bit different than what we've been talking about today, obviously, with the winter forecast, but I just wanted to make you all aware that we do have wind generation forecasts that we provide as well. So these are both graphically on the website and then via data files as well. Wind generation forecasts for all the different regions and for all of the different wind farms on an hourly basis that extend out to 10 days. So we have a wide range of services that we do provide that can certainly help out the trading industry. We have, that 24/7 support, whether it be on the WeatherOps side or on the Frontier side, where you can contact myself or Steve, and all the different forecast capabilities that we do have. So if you do have any questions, feel free to contact us right there at marketing@wdtinc.com, or you can directly contact myself or Steve as well.
Awesome. Thank you so much, Eric. Again, yeah, you can always visit our website at weatherops.com, check out some samples of the reports, but be sure to fill out one of the forms or reach out to us, and we can get you set up with some demo access. I see that looks like Steve answered this question, but I'll ask it for the whole audience here. Question about natural gas demand in the southeast regions, particularly if we get a cold winter.
Right. So there's a lot that goes into total demand besides just the weather. But from the weather standpoint, HDD total should be several percent higher than average. Where it depends on exactly what area you're looking at, but on average, probably 3 to 5% higher than average across that area. And so that will obviously translate to a similar increase in overall demand for natural gas across that area. Obviously, we've seen a lot of trends in terms of increasing production over the last year, which has been strongly influencing things as well in terms of a price standpoint. That will have a carryover impact into overall demand as well, versus, it's different fuels are priced accordingly. But so the economy and the overall pricing could impact demand. But from the weather standpoint, that should favor overall demand being at least a few percentage points higher than average across the region this winter season. And again, for comparison, last winter it was warm across that area, and we did see less demand than average across the southeast. So year on year, it could actually be a fairly large difference across the southeast relative to other areas.
Sure. Excellent. Doesn't look like we've had any other questions come through, but guys, really want to thank you for your time today and the really valuable information. To everybody that's joined us for the webinar, we can't thank you enough for your valuable time and listening to our winter weather outlook this year. Again, you can visit weatherops.com and search a whole slew of information on the products and services we have available, both for long-range weather forecasting, but also if you're interested in our WeatherOps Commander services that provides more of a daily forecast as well as alerting to your company to help make critical weather decisions.